Yeah, now we're going to look a little on PLC communication using schematic as an example, and how communication works, and a little about how to set it up. It's not comprehensive. This is just an brief introduction and overview. Okay, here, if you like TCP/IP, and we probably should nowadays, this is a good tutorial, an IBM Red Book. Get hold of it. I think you get hold of it as a PDF for free. PLC layers and communication between the layers. Down on the layer 0 in the field, we have got actuator, sensor interface, IO link, HART, OPC UA, FX, hopefully in the future, soon, and others too. The Americans, of course, they have their own protocols here. Here in the layer 1, they use Profinet, TCP/IP, or hopefully OPC UA, FX in the future for device communication. The communication down here is controller to device. Yeah, and between the devices, PLCs and the HMI here, proprietary OPC UA and OPC UA FX in the future, hopefully. So OPC UA towards the real-time operating system, up here is TCP/IP with protocols, whatever. So configuration of TCP/IP in TI portal. If you locate here, this is the setup for a communication interface module. So what you have to do is, this is IPv4. There's no IPv6 still, but you set IP address, subnet mask, and a router, default gateway, whatever. So this corresponds to two networks that's connected via router, where you have separate subnets. So here are the subnets, and use the router. And the router has a 1 as the last digit here. It can be any number, but standard is 1. Use 1 if you configure the network yourself. So here are the subnets, and based on the subnet mask, the subnet mask dictates that, okay, the first 3 numbers here are the network address, and this is the device address. And the first device you have is the router, which of course is a device too. And how to check this out? Use the ping, the packet internet grouper ping an address to see if you have any contact with a router or whoever you want to contact. And this is for an interface. Is the left interface on the CPU. So this you do in TI portal and download to your device. You don't have to use a router if all your devices is on the same subnet or segment. So that's why you can opt to use a router. Example CPU 15. There has 2 interfaces. I'm not going to read these. You have 2 interfaces in the front. This is the X1 interface, the rightmost one, because you can use it to make a redundant ring, this network. And the X2 is used usually for HMI communication and so on. And then there is a legacy Profibus interface, because they're still around, and how that's wired and how you configure this. Yes, this was HMI communication, how you do that. This is the Profinet X2, I think, with router and everything and setup, and how it's connected, maybe to a switch or router. Maybe you have a redundant ring here with fibers, with optical fiber. And here's an HMI panel that you communicate, which has an address, whatever. Here we have activated OPC server, and it can be accessed to the interface. It's the other interface here. I think it's not this address, but it's activated from a different CPU through this port, 4840. And here you have got a HMI system on a separate switch or router, which you can communicate with. And maybe this HMI system uses the OPC UA protocol here. And the HMI panel normally use a proprietary CMOS protocol that is configured. And here you have cable options and so on. Depends on the speed. Most it's 100 megabit networks usually, but here is probably gigabit networks. And then there was the second interface here where we talked about hardware redundancy. You can also have redundant CPU and how to use media with redundancy. But the thing here is that you connected all your I/O, this remote I/O or smart sensor and actuators, if they are capable of doing or being a redundant ring. So if you have some kind of failure here or here or wherever, then yeah, if you have a failure here, or we can have a failure here, this interface communicates with these devices and this with these devices. So it's hardware redundancy. Now that's the interface 1. Here we looked at the interface 2 for HMI communication. And here is the legacy Profinet obsolete interface with special cables and special plugs and end resistors. Here is a segment all the way down here, and it has to be terminated by an end resistor, or else you are going to get ringing on the end here, and there's no communication on this network. They have addresses, which is numbers between 0 and 127, I think. They are set by a dip switch, so it's maximum has probably this. But here is how you set it. And you add all these numbers, and then you get an address. For the CPU, it's no dip switch. You usually configure that in software. Yes. And here is how the cable and how these end resistors should work and so on. But it's obsolete. Yeah, that was quick looking into communication with PLC. Used SIMATIC as an example. The SIMATIC has on the CPU, the 1500 has usually two interfaces, two separate network interfaces there. One with one port, use it for HMI communication, programming equipment communication and so on, and another with two ports where you can make a redundant ring for your I/O. So a failure in the ring, a breach, somewhere in the ring does not impair your communication at all.